Well, welcome again. You see, as you proceed with your trigonometric solutions and problems and solutions, you will realize that there will be a question that will come up from time to time that says, solve the following problems without the use of a calculator. In this instance, this is where you are going to be expected to use what we call special angles. And these special angles identified in two methods. The first method would be the method of the two triangles. One triangle indicating your 45 degrees and the three sides allocated in terms of the sizes. And then also another triangle having the 30 degree, 60 degree and the 90 degree angle, also with the sides being given sizes. And then what you need to do in that instant, you're going to have what can I call it, a table in the differentiating between the sine function, your cos function, and your tan function, and then indicating the values for the 90 degree, the 180 degree, the 270 degrees, and the 360 degrees. Obviously, the 360 and the 0 degrees are sitting at the same spot, so they will definitely give you the same figures when punching either cos 0 or cos 360. Right. Let's start with the first one. Now, remember, they said solve the problems without the use of a calculator. So here's what you're going to do. You're going to have a triangle. This triangle will have 45 degrees here and 45 degrees there, and that obviously is your 90 degrees. Remember, a triangle should be supplementary. The angles in the triangle are supplementary, which means they add up to 180 degrees. So this being your hypotenuse, normally represented by r for radius, and then this being, depending on which side you are, could be opposite this angle or adjacent, depending if you're talking about that angle. It's opposite that angle, and then this one is adjacent. And adjacent normally is represented with an X, and the opposite represented with a Y. Okay? Now this triangle has got a figure of 1 here for your opposite side, a figure of 1 there for your adjacent side, and then a figure of square root of 2 on the hypotenuse side. Okay? Now, if you're looking at it from this angle then changes this side to become opposite, which then becomes your Y value. And then this side causes this side to become adjacent, which then gives this one an X value. So that's if you're talking about that angle. and thus is if you're talking about that angle. Right. I hope that makes sense. Now the square root of 2, which is your hypotenuse, will always be your hypotenuse. There's nothing changing there. Alright? Now let's go to the other triangle, which is the triangle having that the 90-degree box there. That would be your 60-degree angle, and that being your 30 degrees angle. Now this side being 1, this side being 2, which is your longest side of the triangle, and then this side being square root of 3. Now for the 30-degree angle, this is going to be the opposite side, which then represents by y, and this being the adjacent side, represented by x value. That's if we're talking about the 30-degree angle. But if we're talking about the 60-degree angle, this is actually your adjacent side, which is represented by x, and for the 60-degree, this would be your opposite side, represented by y. Okay? Now, those are how you're going to allocate those sides. Now, the table I was talking about now, in this system, you are not able to see the functions that will refer to your sine 90, sine 180, sine 270, and sine 360, and sine 0. And also for the cos and the tan.